Alright, this section is about operations on matrices. Okay, like adding them, subtracting them, multiplying them. Okay, so first, just a little bit of notation. We can denote a matrix by a capital letter. Right, so down here, we're saying that A is this matrix, B is this matrix, C is this matrix. We can also denote a certain entry in a matrix, right, by saying A sub ij. For example, if I wanted to denote the this entry right here, okay, I would say A sub first row, second column. Okay, that's what this I and the J means, right? The I is whatever row we're talking about, and the J is whatever column we're talking about. Okay, so entry row 1, column 2 for this matrix would be 3. Right? That's how we would denote a certain entry in a matrix. And a matrix, we've already talked about what a matrix is. It's just a rectangular array of numbers, right? Something like these. So, to add or subtract matrices, all we're doing is adding and subtracting the corresponding entries. So, if I want to add matrices A and B together, well, I'm just going to add the corresponding pieces. So, -2 plus 6 is 4. 3 plus 4 is 7. 4 and -7, -3. -1 and 9, 8, 0 and 8 is 8. 2 and -5, -3.
How did we go from that to this?
I told you this section was easy.
Why didn't we start with it?
Yeah, why did you do the hardest last?
Why wouldn't that make more sense?
Well, that had to do with something that we talked about in the last chapter. Solving systems in 3 variables. How about adding matrices A and C together? That is a good question.
Listen, it says it's impossible. I think it's impossible.
You don't answer the question.
We can add 2 matrices of the same order. A and C are not of the same order.
Dude.
Okay?
That's what I was
So what are the orders of these matrices? We talked about that a tiny bit in the last section on how to determine the order of a matrix.
How many rows and columns it is?
Right, number of rows by number of columns. So what is the order of this one? How many rows does it have by how many columns?
3 by 2.
3 by 2. This one obviously is the same, 3 by 2. And then this one would be a 2 by 2. So since A and C do not have the same order, I can't add them. Okay, this would not be defined. A minus B, okay, subtracting 2 matrices is the same idea. We would just subtract corresponding entries. Okay, so go ahead and try that real quick here. Did we get -8, -1, 11, -10, -8, 7? Right. Questions so far? Okay, so adding and subtracting matrices, all we're doing is adding or subtracting the corresponding entries. And we can only add or subtract matrices that are of the exact same order. So then D says, find a matrix that would satisfy the equation B plus X equals A. Okay? Well, we want to think about this just like an algebra problem, right? I want to solve for X. How would I solve for X in this equation? Yeah, just subtract the B over, right? So we'll end up with X equals A minus B. We already did that. That's the matrix that would satisfy this equation. Okay, in part C here, we did matrix A minus B. So now we're saying, well, this new matrix X would satisfy the equation if we just take A minus B, which we already did. And so we can still use the algebra to solve problems like this. Questions? Alright, the bottom is just as easy. Scalar multiplication. Okay, find the following 2a plus 3b, or b minus a. Okay, so if I've got 2 times a matrix, I'm just going to multiply every single entry by 2. So I'm just going to multiply that entire matrix. So -2, 3, 2 by 2, and then I'm going to multiply the entire B matrix by 3. 7, 9, 8, 5. Okay, so essentially we're distributing this 2 to everything inside the parentheses. Or not parentheses, sorry, inside the matrix. So this would be -4, 6, 8, -2, 0, and 4. Then I'm going to add that to 3 times this matrix. So again, multiplying every entry by 3. So 18, 12, -21, 7, 24, and -15. So now I just add those 2 matrices together. So, -4, 18 is 14, 6 and 12 is 18, 8 and -21 is -13, 5, 4, and -11.
So what's the reason matrices exist?
To organize information.
So, when would you be doing that?
Well, I mean, probably the biggest application is what we just did, solving systems and multiple variables.
I mean, wow. Sorry, I forgot how excited I was.
All right, any questions? Okay. Let's skip B for now. Jump to the back here. So the last operation that we're going to look at in this section is multiplying 2 matrices together. Okay, so we can add, we can subtract, we can multiply matrices. To figure out first if we can even multiply 2 matrices together, the number of columns of the first matrix must equal the number of rows of the second matrix. Okay? So, for example, if I have a 2 by 3 matrix and a 3 by 4 matrix, those can be multiplied together. all we want to look at, okay, I mean, I think the easiest thing to do is write out the orders of the two matrices, and if they have the same number in the middle, then they can be multiplied together, right? So if we have a 2 by 3 and a 3 by 4, those can be multiplied together. The resulting matrix then, when I multiply them together, would be a 2 by 4. So if I have a 4 by 2 and a 2 by 6 matrix, can those be multiplied together? Yes, right? Number of columns is the same as the number of rows. What would my resulting matrix end up being? 4 by 6. Okay? So, in these first two examples here, we have both 2 by 2 matrices, so obviously those can be multiplied together. To do this multiplication, what we are going to do, okay, I'm going to write this matrix a little bit larger. We know our resulting matrix is going to be a 2 by 2, right? But I'm still going to write this a little bit larger. To multiply matrices together, to get this first entry, I need to take each number in the first row and multiply it by each number in the first column of the second matrix.
That's me.
So, what that looks like, okay, I'm going to take 1 times negative 1. So I'm gonna write all of this out first, okay, but once we get the hang of it, we can just write the product instead of writing 1 times negative 1. Okay, so I'm going to say 1 times negative 1. And then I need to take the next entry in that first row and multiply it by the next entry in the first column over here. Okay? I'm going to add these together. So I'm going to do 1 times negative 1 plus 2 times 3. Okay? So I'm multiplying each entry in the first row by corresponding entry in the first column of the second matrix. So 1 times negative 1, 2 times 3. And I'm just looking at this whole first row, this whole first column to get this first entry here. Okay. Now, to get this entry down here, I'm going to look at the second row times the first column. So I'm going to do 5 times negative 1 and 4 times 3. Now to get this entry, I'm going to do the first row times the second column. So I'm going to do 1 times 5 plus 2 times 2. And then to get this last entry, I'm going to do the second row times the second column. So 5 times 5 plus 4 times 2. So now, we can do this arithmetic. So this will be negative 1 plus 6 would be 5. Negative 5 plus 12 would be 7. 5 plus 4, 9. 25 plus 8, 33. So when I'm multiplying two matrices together, I need to multiply an entire row by an entire column and add each of those pieces together. Okay? So I will